Alright, so hello and welcome. We're going to go through another problem called Rabbits in the Forest. I didn't look at the problem, but I did briefly, I opened the problem just to check to see if it's a problem I can do in C++ or not, because I realized I probably should do that in the future. Just to make sure we have the right, have the right context, I guess, the right technology. Alright, so let's go ahead and try to solve it. See how quickly we can do it. So, rabbits in the forest. There's a forest with an unknown number of rabbits. We asked n rabbits, how many rabbits have the same color as you? Collected the answers in the integer array answers, where answers of I is the answer of the ith rabbit. Given the array answers, return the minimum number of rabbits that could be in the forest. Oh, that's interesting. Wow. 1, 1, 2. Two rabbits that answered 1 could be the same color, say red. Rabbit that answered 2 can't be red, or the answers that would be inconsistent. Say the rabbit that answered 2 was blue, and there should be 2 other blue rabbits in the forest that didn't answer into the array. Oh, this is a really interesting question. I think I know the answer, like how to solve this, but this is a bit of a brain teaser. I think I want to say we're going to do something with hash maps and well, actually, we don't really need. Well, maybe. Yeah, hash maps and vectors. I don't know. What could this be? What the minimum might be? I don't know. I think I'd have to run through a few different answers. Oh, we can generate test randomized solutions now with our gen random numbers, which is fun. So we can run through quite a few test cases now, because it's programmatically generated now, our test cases. So minimum number of rabbits that could be in the forest. The 2 rabbits that answered 1 could both be the same color, say red. The rabbit that answered 2 can't be red, or the answers would be inconsistent. Right, okay. So all of the rabbits that answer the same particular number could be the same rabbit. No, that's not true. They actually can't be the same color red, because if 2 rabbits answer that they have the same color, well, actually, it's gotta be at least n rabbits, really. But if they say there's only 1 rabbit that's red, then they actually are both lying, right? Because that would mean there actually have to be 2 rabbits that have red, so they actually can't be the same color. Rabbit that answered 2 can't be red, or the answers would be inconsistent. So the rabbit that answered 2 was blue, then there would be 2 other blue rabbits in the forest that didn't answer into the array. Or is there one other? How many other rabbits have? I think it's how many other rabbits, not just how many rabbits, including yourself. In other words, I guess if the rabbits don't know. I think I've actually seen this question before. It's well, no, I don't want to say I've seen this question before. There's kind of an interesting question of, like, I forget how it goes. Like, there's another brain teaser that uses, like, the XOR function. It's in Cracking the Coding interview, where I think I'm allowed to say that. Yeah, I think it's fair to say that. And basically the idea is that, like, in front of you there are a certain number of people that are either taller than you or the same height as you. I forget exactly how it works, but certain people in front of you, and each person will say how many people in front. I think it's like people in front of them have hats or don't have hats, something like that. So you can figure out how, you give a number of how many people in front of you have hats, and the next person says how many people in front of them have hats, and so on. And you can sort out how many hats there must be in total, which I always thought was kind of an interesting question, because You don't know if the first person has a hat or not. How are you supposed to know if the first person has a hat or not? Right? I don't know. I don't remember. It's something weird like that. I don't know. Some brain teaser. It's kind of, I think it's similar to this, but this is a little bit different. So, okay, so I think it's other rabbits. So this would be, there's got to be 2 other rabbits that say 2. I think that's what they mean. So this is kind of worded poorly. Let's see why they have downvotes. Smallest possible number of rabbits in the forest is therefore 5. 3 that answered plus 2 that didn't. Okay. So these could be red, there could be 2. And then there's got to be, these can't be the same as that, right? So these 2 would have to be 2 as well. So each number you see, there's got to be n plus 1 rabbits with that answer. Otherwise, for each answer x, there must be x plus 1 rabbits with that same answer. Otherwise, they may not be the same color. What's interesting about this, though, is you may not be able to. This really is only interesting when you're dealing with duplicates. Obviously, if the rabbits all give you different numbers, then you would just add all of the numbers together, I guess. I guess it would just be one representative of that group that answered. And so you would, I think you just add everything together. But in the case that there are groups of numbers, like there's a certain amount that could be the same number, that logically would be consistent, then I think you would have to add those together, group those together, and only add that once. So potentially the same rabbits from that group have answered. It's possible that the other rabbits in that group didn't answer. So you could have, so actually, if you have a given x, you could have x plus 1 rabbits. Now what's weird about this is that, yeah, the other 2 could have not answered, but if you, these could be the same color, potentially. They could also not be the same color. In other words, this could be 2 rabbits, 2 rabbits, and 3 rabbits. And also, right, it's x plus 1. So each number actually constitutes x plus 1. So rabbits total. It's themselves and the others. So actually, it's x plus 1. You add for every one, and then you can preclude up to x plus 1 other equal numbers. So that's kind of per group, per color, it would be. So really, actually, the way to do this is the following. I'll show you. I think I have the solution. So we're going to build a frequency map. We can use a vector because the answer is relatively small. It's only 1,000, it's bounded by 1,000. So otherwise, we can use a hash set, or hash map. But we're going to use a vector. So you can use standard vector frequency map. We'll call it, and it's going to be answers.size 0, and we're going to say, yeah, I think I have the solution. So each of these values, though, it's going to be a little bit bigger than that. I think it's going to be, the numbers themselves can be between 0 and 1,000. Answers of I. Oh, actually, oh, it's interesting. Okay. So actually, that's fine. Yeah, size is fine. Okay. We're going to say for constant reference x and answers. We're going to say frequency map of x plus plus, and we're going to take int red equals 0 we're going to say for constant, actually you're going to do it this way, int I equals 0, I is less than frequency map dot size plus I, and you're going to say ret plus equals, it's going to be the following, it's going to be x plus 1, no, not x plus 1, it's going to be frequency map of I, right? So this is the number of rabbits that reported there are, or we'll call it X other rabbits. You can divide this into so there could be I, it's going to be I, right? I plus 1, something like divide by I plus 1. I want to say that's, there could be groups of these numbers, you can group them into sizes of I plus 1. Excuse me, so for instance, if you have a rabbit saying there's one other rabbit with the same color as me, that means you have two rabbits that could be grouped into one section, right? And you would multiply this by I plus 1. And what's interesting about this is, let's say you had 3 rabbits now, let's say, or you have, let's say you could have 3 rabbits with 2, right? So 3 rabbits with 2, they all could be in the same group, right? So it's one group, but it also is multiplied by 3, so 3 rabbits. You could have another 2 rabbits that also have 2. They couldn't be part of the same group. However, those 2 rabbits could be part of their own group, and there could be one other rabbit. And so actually it's not integer division that we're doing, it's going to be division into groups rounding up, it must be. So it's actually going to be, we'll do 1.0 times this frequency map divided by I plus 1, and we're actually going to take the standard ceiling, I believe. Actually, I think this is fine here. And then we're going to convert that to an integer. So this is kind of a nifty thing we're doing. And then you multiply by I plus 1. Now, if you have only one frequency, then you'll have one group, and that'll immediately be sort of upgraded. So the roof or the ceiling of the frequency map value divided by I plus 1. So grouping into groups of I plus 1 where there's at least one group. There's always at least one group. And if you fully complete the group, then you just multiply by the number of groups times the size of the group. However, if you do not complete the group, then there's got to be, all those rabbits need to be contained in that group. And I think that's all you do. I think it's all. So you have an accumulate function that looks like this. We'll use a raw loop here. We could actually write like accumulation routine here. And I wonder if standard ceiling, if I need to include CMath. Okay, so I think that's all you need. And we can actually rewrite this as standard accumulate, and it's going to be frequency map. No, see the problem with this is that we don't have, can we do an accumulate function with the index? I know in Ruby you can do something like this. I think we do need to use a raw loop for this one. What does a binary operator take? Yeah, it dereferences. So actually we can't do the same thing we would do in something like Ruby where you have you you do reduce maybe? No, not quite. You can't quite know. You can, if you really wanted to, you can do, yeah, so I think raw loop is where it's at. If you really wanted to, you can, you could loop over the, well, actually, it's not a hash map, but if you could loop over the hash map, that's another way of doing it, where there's actually a tuple, the frequency map. Yeah, so you could loop over the tuples in a hash map, but we actually didn't use a hash map for this. I think it was a little bit better to use a vector. So I don't think I think we're stuck with a raw loop. I think this is the solution. I think it's pretty straightforward, relatively straightforward. I'm trying to think. Oh yeah, I guess standard ceiling is just a routine, and I've just memorized it by now in C++. So let's generate some test cases. Let's go with a few. Let's actually, we have gen numbers. Let's copy gen numbers. And we're going to say gen test cases. Number test cases. So we're actually going to, this will be interesting, so execute with 4 integer arguments. And what we're going to generate are just random test cases. Basically, high bound, low bound, int, total test cases. Excuse me. And actually what we're going to do is we're going to randomly select the low bound and high bounds. We're actually going to select these test cases we're going to select are going to be randomly selected between for this int distribution. So we're going to have a first int distribution. We're going to have 2 different ones. We're going to have d of, well, actually, let's do it this way. So we actually want to pick random numbers between the high bound and low bound to represent the new low bound and high bound. Generate random numbers for the low bound and high bound. And the low bound, high bound, and the total number to generate. I actually want to do it this way. So total numbers, or max numbers, let's say, total test cases. Okay. For each test case, and then we're gonna say low bound, high bound. So we'll say for int I equals 0, I is less than total test cases plus I. Have a loop to do this, and we're going to say int LB, int HB, int nums, or nums. And each of these are going to be another dgen. Gives you a low bound, dgen gives you a high bound, and we just say if low bound if high bound, if you have low bound or low bound is greater than high bound, then we'll swap. Actually, we can use a standard swap because we're back in C++ here, so we don't need to write out the swap routine. Could swap out low bound and high bound, and then we'll say nums is dgen again, and then we have another standard uniform int distribution that we're going to generate, and it's going to be or a DT for distribution of test distribution, or distribution for the test, or TD we could say. That's probably better. Oops. Actually, TD makes it seem too much like calculus. Makes me think of DDT, DA over DT, or DXDT, for instance. So we'll do TD. Or even DD is fine. Well, TD. We'll do TD. So TD is going to be LB HB, and we're going to say for int j equals 0. J is less than nums plus I plus j rather. We're going to now generate this subroutine, which we'll say is make a lambda expression here. Auto. We probably want this loop to be here, so we'll come back to that in a moment. So we want let's say produce test case as a subroutine, as a lambda expression, and we want to do an int nums, and we're going to say for, and we're going to copy paste this code here. Can I? Oh, all right. Start with. There we go. That's what we want. And then here we can actually, I think we can delete this. Yeah, we just deleted. We can paste it here. Okay. So this is the right spot, that's the right spot. These are mostly in the correct spots, except for these parts. All right. Oh, and there's this part here. Okay, so okay, so that's in the right spot. That's 1, 2. Just make sure we got everything in the right spots, right number of tabs. Okay, so produce test case. It's going to have nums. We have the opening brace, a new line, and total nums. It's actually just going to be nums now. Dgen, we can take a const standard uniform. Can actually just take params. It's probably better. Distribution params. Strib param A. Distrib param B. Or really, it would be high bound, low bound, high bound. Let's do it that way. Okay. We're actually going to go ahead and produce test case of low bound, high bound nums. Yeah, you can do a little bit better than that. You can do delete and then paste, which actually will give you a new line. So that's kind of interesting when you delete. So yeah, you have low bound, high bound. And then we say TD of gen, we need a generator. One more thing, const, where's this generator? There we go. Okay, ready for this? It's gonna be const standard MT 19937 reference called generator. So we have our number generator. Gotta take our number generator with us. Yes. So actually, a little bit of the context has to come with this. TD low bound, high bound. Could actually just take the generator from here too in the context, but we're gonna pass it through. Yeah, and this gets one more. So this is nums, and I think that's all we need. Okay. And the rest of this disappears effectively. Okay, so now if we compile this, let's actually move this to gen test cases. Oh. See if this compiles. Okay. Oh, okay. I forgot the comma. Oh. Whoa. What's going on here? Random. I'm a little confused. The file included. Can you pass this by reference? Passing as this argument discards qualifiers. Oh, okay. Oh, really? Oh. Is this a bug? Huh. Oh, that's interesting. Or maybe you actually can't pass it this way. Maybe it does need to be. Maybe it actually gets modified. Yeah, I guess I didn't really think about that. Yeah. Even though it's a reference, it's still. Yeah, interesting. So yeah, it's not constant because I guess it changes its internal state when you call it. So now we can say gen test cases dot executable. All right. Now we can say from 0 to 1,000, 1,000 and 10 of these. There we go. That'll give us 10 test cases of varying, I guess, types. What are the parameters. It doesn't tell us. I need to write some documentation for this. So we have lower bound, higher bound, maximum numbers, total test cases. So what's interesting is the maximum numbers. No, see, actually, this is slightly incorrect. The lower bound and the higher bound, we're actually going to pick a number between that range of lower bound and higher bound. So all of our lower bounds and higher bounds will be in between that range. But actually, it's actually programmed incorrectly. The total number of numbers that we can have, those are actually it's not going to be in the same range. This is actually a totally different distribution. It's going to be 0 to max numbers. Yeah, so we're going to say the test case distribution was TD, the N distribution, we'll call it ND. We're actually going to put it up here. All right, so ND, and this is going to be ND gen, believe it or not. Believe it or not. Let's see if it compiles. Nice. Let's take a look at these. So we can actually pipe this into interesting. So we have each of our test cases. 10 different test cases. How's that for automating your testing? How's that? Runtime error, no. Really? Huh. Oh, these need to be between. It's interesting that we didn't get also a few things. We didn't try this 10, 10, 10. And another one is it's actually 999. I got this wrong before. It's interesting that it doesn't seem to. There doesn't seem to be any issue with the invalid test cases. The invalid test cases won't fire when you put in answers that are larger. Oh, really? Oh, that's interesting. You don't seem to get invalid test cases when you don't seem to get invalid test cases to fire when the. Oh, that's really. I don't know what's going on now. Something weird's happening. Don't seem to get invalid test cases when the answers of I is greater than 1,000 for one of the numbers. Oh, so what's going on? Why is it? Whoa. Runtime error. We can come back to this momentarily, but excuse me. Where's the runtime error? What? What is going on? Check. I don't think there's a runtime error. It could be the hash map. I mean, that's what I'm thinking. Oops. What's going on? The frequency map. So, oh, duh. Got it. I see the problem. Yeah, I see. Okay, of course. That's my mistake. I kind of didn't really think about that. That was really dumb. Yeah, because we're using constants, so we would say constants that are unrelated to the answers. So we're using this answers of I. If we use a hash map, a regular hash map, this wouldn't even be a consideration. But but I forgot to use a constant that we're using sort of outside of the program. I did input, so we'll say max value or max size. Not max size. It's actually like max answer. Yeah, it's probably constant max answer equals 1,000. So we say it's actually going to be max answer, something like this. See why we get the runtime error. Okay, fair enough. All right, I think we got it. Oh no, wait, yeah. There we go. Okay, sweet. Pretty straightforward. Yeah. So if it's quick enough on those test cases, it should be fast enough. So pretty easy question overall. Probably should have been able to solve that a little bit faster. Obviously, I wanted to test it before I. It's nice with LeetCode. You kind of have the opportunity to test things a little bit. Have the opportunity to test things in such a way where you can check these test cases against their code. I like that a lot. I appreciate that a lot. So this, we could probably optimize this with a hash map. I think we're going to do that anyway. Unordered map is what you want. I think it's a little bit better with an unordered map. Of int to int. And we're going to say we don't need this max answer anymore. And then this is just empty. And we would say same thing here, right? So this will actually generate the key at 0 by default. And then here we can actually accumulate. And what this will look like is you have frequency map begin, frequency map end. The rest of this can just be commented out. And you're going to have two things. You have a Lambda expression for the binary operator, and you have the initial values. The initial value will be 0, and the Lambda expression, so I should put that here. And the Lambda expression will be as follows. It's going to be a standard pair of int reference p, and we're going to have an int total or accumulation const standard pair, and we're going to say the accumulation is going to be plus equals this routine where we would say something like the following. Can actually make this a auto op. It's maybe better to do it this way, so that way it's over here. Yeah. So it looks like this. And we can put the operation here. Yeah, I think this is a little bit more, it's not much cleaner, but const auto, we can say AB really, or just key value, KV is probably better. KV equals P, and then we could say I is, so frequency map of I is V, K is I, K by K plus 1. This is a little bit better, I think. I think we can do it this way. Let's see what happens if we do this. Incompatible with type void. Let's try this again. STL can be a little challenging to deal with from time to time. So we have first, last, init, op. We should take a look at op. Type 1, type 2. Does not need to have const reference. Type 1 T can be converted to type 1. Type 2, type ret. Oh, I see. I think you return, actually. I see. I think the problem is actually that we're going to return this value. Is it like this? Is this what we want? I'm actually not sure. Okay. Now is that faster or slower than what we had before? Okay. It's about as fast. It actually uses more memory. I think the first one I had was better. Actually, yeah, it's not much better. But it's a little bit cleaner. Let's go back to what we had. I liked what we had originally. I thought it was pretty good. I think the ceiling function is part of the issue here. I'm not really sure how we can speed that up, quite frankly. Hey, there we go, 100%. All right, nice. We'll just use a little more memory, but we got there. Okay, good. Yeah, I think you're usually better off not using hash maps if you can avoid them. It's usually quite a bit faster. Sweet. So, all right, well, that's 40 minutes. So let's go ahead and end here. Thank you for watching. I'll talk to you soon. This is it's been interesting. I'm not sure what else I want to say here other than, yeah, I mean, you could solve this one very quick, I think. Okay, I'm gonna go. Thank you for watching. Take care.